The fundamental theorem of calculus can be used to find values of a function f given values of its derivative f prime. So let's see this in action. So here we have the graph of a derivative f of f prime, and then using the graph of the derivative that's given to us, we'd like to complete the table of values for the function f. So here's the function f, and what I am given is what happens at time equals 0, or at x equals 0, the value of f of x is 3. And then using the fundamental theorem of calculus, I can complete the table. So how does that work? Well, the fundamental theorem of calculus, the FTC, tells me that the difference between f of b and f of a, the values at a and b, are equal to the integral from a to b of f prime of t dt. And that's another way of saying that is that f of b is equal to, well, what you start with at a plus the change, the total change between a and b, that's the definite integral, f prime of t dt. So that's how we're going to use it. And in this example, since we're going to be using f prime as a graph, we're going to interpret this as the area under curve, or over curve if it's below the x-axis, between a and b. Okay, so let's see how this works for this example. So to find the value at 2, well, I need to know what's the change that occurs from 0 to 2 in the function f. Well, the total change in the function from 0 to 2 is given by the integral between 0 and 2 of f prime of t dt, which in this case is going to be the area between the x-axis and the graph of f prime. Now this area, that's a triangle, so it's 1/2 times 10 times 2, which is equal to just 10. So the area of this triangle is 10. But notice it's a minus 10 because we're working with below the x-axis. So the total change in this particular case is minus 10. Okay, so the value at 2 is equal to the value at 0 plus, in our case, minus 10. And the value at 0 is 3. So f of 2, the value at 2 is 3 minus 10, which is minus 7. In other words, between 0 and 2, the total change is minus 10. So if I start at 3, I end up at minus 7. Okay, for the next one, to go from 2 to 4, we look at the total change between 2 and 4. The total change, if this is the derivative, is the integral of the derivative, which is the area. And that blue area, very similar computation, shows that that's 10. And it's counted positively because it's above the x-axis. So we have an increase of 10 from minus 7, which gets us back to 3. For the next interval from 4 to 6, the area under the curve is actually 20. Base 2, height 10, 20. So that means we have an increase of 20 from our base of 3. So 3 plus 20 is now 23. To go from 6 to 8, I look at the area here, and that's another area of 10. So to go from 23 to 33, because I'm working positively. And then finally, the curve between 8 and 10, the derivative is 0, which means there's no change at all. The rate of change is 0, so I don't add anything. I stick at 33. So in each case, to go from one value, if I know f of a, I can go to f of b by adding in the integral of the derivative, which is the area under the curve for the graph of the derivative.